Welcome to this interactive study guide on material properties. In GCSE Design and Technology, examiners want you to justify why a material is chosen for a product. This requires a deep understanding of performance characteristics, how materials behave under different conditions. Today, we'll explore the 10 essential properties that will help you make informed design decisions and secure top marks. Let's map out the 10 core properties. Conductivity is key for electrical wiring and saucepan bases. Strength comes in 3 types: tensile for pulling, compressive for squashing, and flexural for bending. Elasticity lets materials like rubber band snap back. Plasticity allows metals to be pressed into car panels. Malleability lets you hammer aluminium into foil. Ductility lets you draw copper into wire. Hardness is vital for cutting tools. Toughness prevents phone cases from shattering. Durability ensures garden furniture lasts outdoors. Biodegradability helps with end-of-life disposal. Now let's look at the exact definitions from the specification. Conductivity is about allowing heat or electricity to pass through. Plasticity means permanent deformation without breaking, crucial for forming processes. Hardness resists scratching and wear, important for drill bits. Toughness absorbs impact energy, so safety helmets don't crack. Durability means long-lasting performance outdoors. Biodegradability is key for sustainability questions. Natural materials like wood break down, while synthetic polymers persist. Here's a step-by-step process for material selection. First, identify what the product must do. Does it need to conduct electricity, resist impact, or be lightweight? Second, list the properties that match those needs. Third, compare possible materials. For wiring, copper is more conductive than aluminium but heavier. Fourth, factor in cost and sustainability. Recycled aluminium might be cheaper. Finally, justify your choice using property terms. For example, I chose copper for electrical wiring because of its high conductivity and ductility, allowing it to be drawn into thin wires. Let's work through a typical 6-mark question. Explain why a saucepan base is made from copper and its handle from a polymer. Start by identifying the required properties. The base needs high thermal conductivity for even heating, and the handle needs low thermal conductivity to stay cool. Copper is an excellent conductor and also malleable for shaping. Polymers are insulators and tough, so they resist breaking if dropped. Always link each material to its specific property and how it meets the product's needs. Watch out for these common pitfalls. First, don't confuse strength with toughness. Strength means resisting a steady force, toughness means absorbing a sudden impact. Second, always specify the type of strength: tensile for pulling, compressive for squashing, flexural for bending. Third, never just say it's a good material. You must name the property and explain why it's suitable. For example, aluminium is used for aircraft because it has high tensile strength relative to its density, making it lightweight yet strong. To recap, master these 10 properties: conductivity, strength, elasticity, plasticity, malleability, ductility, hardness, toughness, durability, and biodegradability. When answering exam questions, always link the material to a specific property and explain how it benefits the product. Use precise terms like tensile strength or thermal conductivity. And don't forget sustainability, biodegradability, and recyclability are increasingly important. With this knowledge, you can confidently justify any design decision. Good luck with your revision.